All right. Good afternoon. Happy Wednesday. I don't know about you, but I'm exhausted. When we have to go to all the classes, it just wipes me out. So I know if you feel the same way, I can sympathize with you. I have a couple of announcements I want to go over. First of all, be careful of following the step-by-step in my HRW. So I cannot guarantee that it's efficient. I can't guarantee it's teaching it the way I am, and it could be causing confusion. So the reason why I'm saying this is because I was looking at your remember the exam where you had to find the inverse? And I noticed that students were switching the X and Y at the end. I did not teach it that way. So it makes me think that you're doing the step by step. Now, the problem with that is it could be causing confusion. For instance, sometimes parents will say, well, shall I get them a tutor? And I'm like, yeah, if it's one of my former students, yes. If it's not one of my former students, absolutely not, because I don't want a tutor causing confusion if they're teaching it a different way or not teaching correctly, correct concepts. And so you have to be careful about getting too many different ways of doing things that might be causing problems. Because in my opinion, you have everything you need in your notes. So when we're at school, I always make a trip over to Avid. And I always tell the Avid tutors, don't teach them. Keep referring them to my notes. Because if you're teaching them a different way, it could be causing confusion. So everyone should be directing you to your notes, to your notes, to your notes. We don't want a bunch of methods out there that are going to cause confusion. Okay, I think I mentioned this the other day. Remember that lesson 12.1 is in your second book, volume 2. And remember that I told you the answers aren't always correct. So first of all, in the practice AB, they're not restricting the domain from like 1 to 5. Well, that's not right. So if a table goes from 1 to 5, you have to restrict the domain. So they're writing it correctly in your book, but not practice AB. In addition, the recursive rules? I'm having you write the first term because without the first term, whether it's in position 0 or 1, you can't use the recursive rule. And neither your book or the practice AB is doing that. I don't care what the book's doing. You want to be able to write math correctly and completely with correct notation. And then finally, I stress the importance of knowing the difference between these two. So this is a function of something. This is D times a quantity. The two totally different things. So this is a function of something. This is D times the quantity n minus 1. Okay, now, third period upset me because I asked them if they had any questions in 12.1 and nobody has any questions. So that means they either know everything that's going on or they didn't start the lesson. So I'm warning you, I'm already on edge today because I looked at your exam scores. Now, some of your exams, they look fine. Some people are getting 100% in the A's. I'm not having a problem with that. That's fine. You still want to work on your notation. You want to make sure you're showing right work vertically. But those of you who are getting like an 8%, 10% on an exam, that's inexcusable. So I know I'm not that bad of a teacher. So get with it. There's no excuse for getting those types of grades. And here's the deal. You can give up, But that's not a very good routine to get in because life is going to be hard. And if you start giving up now, you start giving up in real life, your life is going to take a downward spiral. You always, I don't care if you learn anything else from me this year, always finish what you start. So if you're not happy with your grade right now, do something about it. Meet with me, talk with me, ask me questions before an exam. Figure it out. I'm going to give you the grades you want, but you have to do something. I'm not going to give it to you. Because real life is not going to give you one single thing. There is nothing free in real life, nothing. And I don't care what people say. Oh, you can get this for free, you can get that for free. Nothing's for free. So might as well learn it now. All right, so I want to take any questions you have about 12.1, but I'm going to teach part of 12.2 today. And we only have 45 minutes. And so anybody have any questions about 12.1? Well, in the practice AB, they wrote the answers like this for the domain. That's not right. Because if you have a table that's less than or equal to 5 and greater than or equal to 1, that's the domain, not that. If you have a table today with geometric sequence, you're going to see a table that goes on forever, then it's okay to write it like that, but not one that has a beginning and an end. Okay, last call. Any questions for 12.1?
Can you hand me a pencil? Or a color pencil or something?
Yvette, can you mute yourself, please? All right, so in 12.1, we were looking at arithmetic sequence, and now we're looking at geometric sequence, California Common Core Standard F-BF.2. Let's look at the definition. So we know that an arithmetic sequence is a sequence that has a common difference. So a geometric sequence is a sequence that has a common ratio, and ratio means fraction, and it's R. Rules. Is f of is equal to a times r to the n, where n is greater than or equal to 0. The starting position is 0. And the other one is f of n is equal to a times r to the n minus 1, where the starting position is 1. Is the position number, and R is the common ratio. So you have one recursive rule And it looks like f of n is equal to r times f of n minus 1. And they don't show a domain because if it's this explicit rule, the domain over there is n greater than or equal to 1. If it's this one, it's going to be n greater than or equal to 2 over there. So they just don't put it, assuming that you know what you're doing. So the first thing they want you to do is they want you to, given a table, they want you to write both rules. So they give you an x, which is n, and a y, which is f of n. So the positions are 0, 1, 2, 3, 4. And then look at how this table is. It's a dot, 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 and then a j minus 1 and a j, and then a dot, dot, dot. So this table goes forever. And the position 0 is going to be 3, 1's going to be 6, 12, 24, 48, dot, dot, dot. AR to the n minus 1, AR to, I meant j minus 1. Dot, dot, dot. So that is a never-ending table. And they want us to write an explicit rule and a recursive rule. We want to find the common ratio. So we're going to take 6 divided by 3, 12 divided by 6, 20, we're dividing 24 divided by 12, and that shouldn't be 24, that should be 48. 48 divided by 24, and see if we have a common ratio. So 3 times what is 6, 2, 3 times what is 12, 2, 12 times what is 24, 2, 24 times what is 48, 2. So your common ratio is 2. So our explicit rule, excuse me, our explicit rule, we're starting at 0, so we're using this one, is f of n equal to a times r to the n, where n is greater than or equal to 0. So f of n would be the starting term, which is 3. Now, let me change this to 6, and you can't multiply before you evaluate an exponent. So you have to follow the order of operations. So you see that 2 to the n? You cannot multiply the 3 and the 2. It has to be left like that. Now, I like to use parentheses, but you can use a dot. I don't recommend the dot to show multiplication there. You're going to see it. Doesn't mean we like it. So that's the explicit rule. Let's write the recursive rule. So the recursive rule is f of n is equal to r times f of n minus 1. And I'm going to put the domain. So since our starting position was 0, our domain here is so we have f of n is equal to the common ratio times, you can put a dot there or not, where n is greater than or equal to 1. And I'm also going to put f of 0 is 3. So remember what I said, the recursive rule, when you put a 1 in, you get f is 0. So without putting f is 0, the rule is useless. You can't even use the rule. So practice AB isn't doing this. The book isn't doing this, but I recommend you do it because the rule is useless without it. You're only doing that on the recursive rule. Okay, anybody have any questions? You ready to try another one? Can you guys give me some feedback, please? Anybody have any questions?
I'm good.
You guys okay?
Yeah, I'm good.
Let's look. X and Y. 2, 3, 4, 5. Dot, dot, dot. So that means it goes forever up until j minus 1, j dot, dot, dot. So in these slots or position, you have 1 over 25, 1 over 5, 1, 5, 25, dot, 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 a times r to the j minus 1, a times r to the j, dot, dot, dot. So the domain is not restricted. Common ratio, and I'm not going to write it like this, 1/5 divided by 1 over 25. I'm not going to write it like that. That's confusing. So I'm going to write it like this, 1/5 divided by 1/25, 1 divided by 1/5, 5 divided by 1, and 25 divided by 5. Now, do you guys remember that when you divide fractions, you have to change it to multiply and take the reciprocal? Remember that? So this really means 1/5 times the reciprocal, which is really 1 times 5 over 1 is 5. Did you follow that? Hello?
Yeah, I get it.
Okay. So this would be 1 times the reciprocal, 5 over 1, which is 5. 5 over 1 is 5. And 5 times what is 25? 5. So your common ratio is 5. Okay, does anybody need me to do that again so you can see what I did? Okay, so the explicit rule for this, the starting position is 1. So it's going to be f of n is equal to a times r to the n minus 1. And the domain should be n greater than or equal to 1. So our explicit rule would be f of n is equal to the starting term, which is 1/25, times the common ratio, to the n minus 1 where n is greater than or equal to 1. And you're not going to try to cancel this, right? Because you would violate the order of operations. You have an exponent. Okay, so the recursive rule for a starting position of 1 is going to be the same as the other one, but the domain is going to be different. This is going to be r times f of n minus 1, where n is greater than or equal to 2, one more than the explicit. And so this would be f of n equals the common ratio, which is 5, times, you could put a dot and just write f of n minus 1 times, where n is greater than or equal to 2, and you want to put the first term as 1 over 25. And why are we doing that? Because when you put in a 2, you get 5 times f of 1. So you need f of 1 to do the recursion. Are you guys okay?
Yes.
Okay. All right, now remember with arithmetic sequence, we graphed. So we're going to graph the geometric sequence. And I said this last time, but this time I'm going to write it. The domain, which is the position n, the domain consists of only whole numbers. Don't connect the points. Can somebody explain to me why we don't connect the points and why is n only whole numbers? Go ahead, I'm listening. What's this mean? N is only whole numbers, don't connect the points. Why? If somebody asked you why can't I connect the points? I always connect the points. What does N represent?
Position number?
The position number. So can the position number be a fraction?
No.
Can you have a position of 1.5? Can you have a position of 5 square root of 3? No, you cannot. So that's what this is saying. This is saying that since the domain is the position number, they can only be whole numbers like 0, 1, 2, 3, 4. No fractions, no decimals, only whole numbers. Okay, now in this next problem, I'm going to give you a rule and they want you to graph. And remember, we can use a calculator. So grab your calculator. And somebody in third period said, Ms. Birch, where's the N? You guys, we're always using the variable, which is next to the alpha key. We're always using X. So whether the variable is n, z, t, v, we're always using x. That is our variable on the calculator. So on the calculator in the equation editor, you're putting 2 times 2 to the x. And off the calculator, I want you to tell me the values. I'm going to fill in my table. So what did you get for position 0? This is an unlimited table. What did you get for position 0?
Y equals 2.
Okay, what about position 1? Let's go, guys. Shout them out. Position 1.
Y equals 4.
Go ahead. What about position 2?
Y equals 8.
Yep. What about position 3?
Y equals 16.
Go ahead. Next, 4. And yeah, now we might not graph those by hand. I'm going to graph as many as I can. So 0 up to, make sure that you, in pre-calculus, make sure that you, in Algebra 2, label the axes X, Y, make sure you use a ruler and or scratch paper, make sure your tick marks are evenly spaced, make sure you label the axes, right 1 up 4, right 2 up 8, right 3 up 16. Doesn't it look like it's going up exponentially? Yes? Something to think about? So how many points do we graph? I don't know, 4, 5, or 6. I mean, graphing 2 or 3 points, that's not sufficient. You have to do like 4 or 5, 4 or 5 or 6 points. You have to get a representation of the graph. Okay, let's do a recursive rule, because unless you have your calculator programmed, we have to do a recursive rule by hand. Can I erase this? You guys okay with the calculator?
I don't really understand how to put it into the calculator, like to get the values.
Go into the equation editor, y equals, clear it out. Under y sub 1, you're going to put 2 times 2 to the x. Two, and then you could put the square key. No, you can't use that one. 2, okay, I erased it. 2 times 2 caret x.
Okay.
And then hit second graph for table. Second graph for table.
Okay, I got it. Thank you.
Okay, did everybody get these values? 2, 4, 8, 16, 32. So now they're going to give you a recursive rule And I want you to notice what they give you. They're giving you what I'm trying to get you to give me when I ask for a recursive rule. Watch this. They give you the rule, 0.5 times the function of n minus 1. They give you the domain is n greater than or equal to 1. Look what else they give you. They give you f of 0 is 16. So look at, aren't they giving you the term in the first position, 0? So I'm going to show you a different way. If you don't like making a table, I'm going to show you a different way. Check this out. We know that f of 0 is 16. So what's f of 1? Well, f of 1 would be 0.5 times f of 1 minus 1, which is 0.5 times f of 0. Well, what's f of 0? $16, isn't it? So you see I'm taking out f of 0 and putting in 16? So what's 0.5 times 16?
8.
Now, I can explain this in color. Anybody want me to show you this in color? Last call. Anybody want me to explain this in color? Nope. All right. So now we go to x equals 2, or n equals 2. So that would be 0.5 times f of 2 minus 1, which turns out to be 5 times f of 1. So what is f of 1?
8.
So what's 0.5 times 8?
4.
So now we go to f of 3. So that would be 0.5 times f of 3 minus 1, which is 0.5 times f of 2. Well, what's f of 2? 4. So what's 0.5 times 4?
2.
Okay, let's do a few more. F of 4 is going to be 0.5 times f of 4 minus 1, which is 0.5 times f of 3. What's f of 3? 2. So what's 0.5 times 2?
1.
Let's do one more. F of 5 is equal to 0.5 times f of 5 minus 1, which is 0.5 times f of 4. Well, what's f of 4? 1. So f of 5 is a half. So we're going to do the graph. So the first thing we're going to graph is this, 0, 16. Are you guys there? 0, 16. So 0 up 16. Right 1 up 8. Right 2 up 4. Right 3 up 2. Right 4 up 1. And right 5 up a half. Doesn't this look like decay to you? Looks like decay, doesn't it? By the way, f of 6 is 0.25. So it's not going below 0. Okay, so that is the lesson for today. You're welcome to hang out with me and ask questions if you're confused about the recursion, or if you're confused about the calculator or anything else. I'm going to turn off the recorder right now. So if you're all cool and you know what's going on, have a great day. Otherwise, if you want to ask me some questions, you can do that. But I will see you guys on Friday. All right, have a good day.
Have a great day, Miss Birch.
Thank you, April.